All right, Jeff, welcome to the show. Thanks for joining us.
It's great to be here. Thanks for having me.
Let's start with a bit of an overview for those who aren't familiar. What exactly is Apollo? What sets it apart?
Apollo is a humanoid robot that we develop here at Apptronik. We're now on our ninth generation of humanoid robot. So, as you might imagine by the name, the roots of Apptronik are out of NASA. A couple of my co-founders were part of the Valkyrie team with NASA Johnson Space Center during the Dark Robotics Challenge, and we've been really working on, bringing humanoid robots out of the lab and out into the real world for many years. Apollo is an industrial humanoid robot, so initially working in areas like manufacturing and logistics, but we have big hopes for Apollo in the future of where it's going to go.
We'll get into those hopes in a moment, but you mentioned Apollo's on its ninth generation. Can you just give us an example of what the biggest differences are between the first generation and now the ninth generation? What have been the biggest innovations?
Oh man, there's all sorts of innovations. So the company started in 2016, and it wasn't always called Apollo. There was a variety of different robots that came before. We kind of have kept with this space theme, I guess, if you will. So we had Astra was another robot that came before. A lot of the innovations have been in the hardware itself. So the way I sort of think of how do you commercialize a humanoid robot is a two-part problem. So problem number one is, can you build a viable humanoid robot that can do the things that you wanted to do? But then you also have to make it affordable and robust and easy to maintain and service. And so there's all sorts of innovations that have gone in to make that happen. The core building block of a robot is the actuators. These are kind of like the muscles of a robot. You can think of a robot in some ways as a network of actuators, a network of motors. So a lot of the innovations that we've made have been in the actuators and electric actuators specifically. There's different technologies you can use. So we've done over 60 iterations of electric actuators, and this is kind of what drives performance and cost and scalability of the system overall. And so that's where a lot of the work has gone into, really finding the sweet spot of the right technology approach for actuation as a whole, but new compute, new types of sensors, new cameras, better batteries, kind of you name it, we've iterated on it over the years to get to a commercial version of Apollo that we can actually get out of the lab and really start to scale and get out into the world.
The simplified version, as you said, is you're trying to get robots to do the things that you want them to do. How do you decide what are the things that you want them to do? I.e., what are the problems that you're trying to solve here? Where are robots the most relevant and helpful now?
Yeah, well, I guess so. I'll answer the question about now, and then we can also talk about the future, about where they're going. I sort of joke that I've spent my entire adult life thinking about how to commercialize humanoid robots. So you name it, I've probably thought about it and talked to various leaders at companies and in pretty much every industry, everything from industrial to even oil and gas and energy and nuclear waste, and of course in things like healthcare and in elder care, which is an area I'm very interested in long term. My view for humanoid robots is they're going to happen in three phases. So phase one is industrial activities. This is like logistics and manufacturing, places where we already have robots today, but this is kind of the dream for what a robot could be, a highly versatile, capable robot. Stage two is commercial applications, things like hospitality, retail, and healthcare. And then stage three is the big market that I think everyone's excited about. This is where you finally don't have to fold your laundry anymore or do your dishes or any of the stuff you don't want to do around your house. This is the home. So the home and assistive care are sort of bucket in the same. And so we're sort of moving across the spectrum of going, think of it in some ways of easy to hard, although all these things are hard on a relative basis. But starting in manufacturing and logistics, that's where we're working today.
So I think maybe our audience might be quite interested in that last phase of humanoid robots in your home, helping you with your everyday tasks. From a very basic standpoint, why are these tasks harder Why is it a hard problem to solve? And which use cases are you most excited about that would impact the regular person's everyday life?
Yeah, I think so. So the way we talk about this in robotics is we say structured to unstructured applications. So structured applications are applications where you can control the environment in some way. So if you look at manufacturing, you can control where things are placed or who's coming around that robot. So you can control for safety. Unstructured is highly dynamic, highly variable, a lot more complexity. And so you can think of the bookends maybe of the market is a manufacturing floor is highly controlled. You can control everything that comes at the robot. And then a home is maybe the most unstructured. So some people's homes are more chaotic than others. You have stairs, you have different, sizes of homes and different environments inside of the home. And so the home is the most chaotic. The other thing that's a challenge is how intermittent a task is. So the variability of a task. So if you look at manufacturing, you might be able to do the same thing for 24 hours all day long. This is very structured tasks. Even the most intermittent tasks are usually on shifts, so they could be a 2-hour task or a 4-hour task. When you look at the home, it's very variable, very dynamic, and very short tasks. How long does it take you to fold your laundry? Maybe less than an hour, depending on how often you do it. How long does it take you to cook or clean up? These are tasks that are sub 1 hour, sometimes 10, 20-minute tasks. And so you have to stitch together a lot of these tasks, and they're all very complex in their own right, to be able to really have to show value inside of the home. I think different people will have different things they want the robots to do. I think the robot will be sort of the nexus of the home where you will still have. This doesn't mean you're going to get rid of your washing machine and the humanoid's going to clean your laundry over a bucket because you don't need any other machine. You'll still have special purpose machines, but you will have a robot that sort of interfaces with all of these machines that will do all sorts of things. Cooking, cleaning, your garden work if you like that. I even think there'll be really interesting things. Like I have this dream that my robot will read to my kids, and it will read, in perfect character of the book, and it can download the voice from the author or from whatever the Buzz Lightyear or Woody or whoever the character is that it's reading, and it can do all the voices and it can interact. So there's all sorts of things that robots will do in the home over time, and I think they'll have different value for different people. For me, I think the biggest impact that these robots will make in the home will be for our aging populations and for people that really need some type of assistance in their home. I think that will really improve society in a big way, and that's kind of the big dream for us long term.
Yeah, clearly a lot of different use cases, and I'm curious what the timeline and roadmap looks like. I understand you raised several hundreds of millions of dollars in funding from the likes of Google, Mercedes-Benz, the Capital, and more. What does the roadmap look like? When will we see robots participating in elder care? When will robots be folding my laundry, reading to me? I don't have kids, but maybe reading me a bedtime story.
Yeah. So, we're getting robots out into the world today. They're still in the pilot phase for us, and these are these industrial tasks. So we have great partners like Mercedes-Benz and GXO and many others that we'll announce throughout this year. I think bull case is probably, if you're the most aggressive, is probably 5 years out where you start to see, real applications. But in terms of scale, I think that's like between 5 to 10 years out. I've talked to a lot of really smart folks in the space, really leading pioneers, and their view is it's probably closer to 10 years before you see real uptake in the home. So there will be early adopters that will want to, pilot these robots and test these robots in the home, but there's still a lot of problems to solve, both on the sort of capability of the robot, how many tasks would that robot have to do, and what would you be willing to pay for that robot? Say you can only do your laundry. How much would you pay for that? say it only did your laundry and only cooked for you. How much would you pay for that? So you really need a robot that can do all of these things before the cost of the robot, for the economics really makes sense. And then you have safety. So if you're dealing in the home, if you're dealing with, your 2-year-old or your 90-year-old grandmother, then the safety cases become really important. And there's still a lot of technical challenges for us to solve to get there. But it is happening very fast. I think we are on an exponential curve. There are really smart folks that are working on humanoids for the homes today, and I salute them. I think it's a tough challenge, but I think for us, we're taking a different path and really focusing on what I call commercial viability of humanoids, really proving that they're useful and getting them out into the world, learning by these early applications and sort of setting the tracks or laying the foundation for the home and assistive care long term.
What are some of those maybe more specific milestones you might need to hit to prove that commercial viability? I know that Mercedes-Benz is training Apollo on its factory floors, but how do you get from pilot into full production and actual commercial use?
I think of that as just a 2-phase process. It's more complicated than that. In phase 1, there's multiple steps, but think of sort of step 1 is, can you do the thing? Can you do the task? And can you do it at a rate that makes sense? So depending on the cost of that robot, sort of fully burdened, you sort of compare that to what it costs today to do a particular task and then say, does it make sense? So if it's 80% the cost, then you can get away with it being 80% the rate, right? If it's half the cost, it doesn't have to be as fast as the way tasks are done today. But step 1 is you have to do it at, sort of KPIs that actually make sense. So can you actually do the task, and can you do it in a way that is economically viable? Then stage 2, there's things like safety and security, where you actually have to integrate the robot, and you have to be safe enough, or you have to solve these safety cases in the environment. So generally what we're working on today is really proving out the robots in these applications, getting them up to rate where they can do the tasks successfully enough and fast enough where it makes economic sense, and then starting to work and actually integrating that, and then working on safety in parallel as well. And you need all of that to happen before you can get real uptake. So in the humanoid sector today, we're seeing purchase orders and start to get signed, but those are early purchase orders for relatively small quantities. And so this is still early days for the industry as a whole, and this will really accelerate over the next year and the years ahead.
You mentioned safety a few times. How do you also think about psychological, emotional hurdles for humans, who are deciding to purchase robots for the home?
Well, I think a lot about it. The lab that we came out of was called the Human-Centered Robotics Lab. And so we've been studying human-robot interaction, HRI, for many years. So thinking about what is it like to be around a robot, and how should we design robots such that they're really optimized for humans to think of it as, user experience for people that are going to be using these robots overall. One of the things that you might notice if you see Apollo, a lot of people say Apollo looks really friendly. That's a byproduct of a lot of this human-centered design thinking that we've put into Apollo, where everything from the industrial design of the robot to the interfaces that we're using on the software side are really designed to be easy to use and more approachable, and hopefully more adoptable by humans overall. I think there is baggage that comes with the humanoid form factor. There's good things and bad things. In the West, we have science fiction that's done a good job, I think, of warning us about some of the traps we might fall into as this technology develops. But in other cultures, there's things like manga, where kids grow up being really excited about these types of robots and what they can mean in the future. And so I think the real question for us is, we will have robots, but what do we want the future to look like? What kind of world do we want to live in? And my view is that we can have these kind of industrial, lifeless machines that we have today, where if you go into a factory, these robots have no character, they have no design. Or an alternative future is we have these robots that have character and design, and they're designed with intention. And to me, that's a much more optimistic version of the future, properly done.
A question I'm sure you get a lot is around thinking about humanoid robots potentially displacing jobs or fears of job displacement for humans. What is your response to that? What are your thoughts on that topic?
I think that's a natural reaction, to any new technology, especially a technology this powerful. These are the same fears that we had in the computer revolution, right? There was a lot of, this is really just a continuation of computers. You can kind of think of a robot as a computer that can interact with the physical world. Maybe sort of one meta story to think about is computers have gotten good enough to go from the digital now to the physical world. So you're hearing all this talk about physical AI. And so I think you have to be mindful about what the robots are doing. Just because you can doesn't necessarily mean that you should. But I think that much like computers, 20 years from now, we'll sort of look back and it'll be hard to envision our lives without robots. If you look at the industrial base, we have a big labor shortage today. So we have these demographic trends that I think are sort of going to hit us in two ways. So it starts with the labor shortage, where you have an aging, shrinking workforce, especially in the developed world. But the impact of that on the back end is you have an aging population without the same number of young people to take care of them. So sort of stage one is let's shore up the activities that we need to keep society functioning as a whole. And then stage two is, how do we actually take care of this aging population and improve the way that we age long term?
Yeah, I think there's probably a misconception out there that humanoid robots are being built just for fun, just because it's a cool futuristic thing to do. But it's clear that you're actually thinking about, these problems that exist and use cases that are filling gaps. So that's very interesting to hear. In terms of U.S. manufacturing as well, obviously the U.S. is putting more emphasis on reshoring, bringing manufacturing back to the States. How do you see humanoid robots like Apollo fitting into the future of American manufacturing?
Yeah, I think the only way we're going to reshore, the only way we're going to be successful at, really improving our manufacturing base is going to be with robots. And I think not just humanoids, there will be a whole variety of different robots that will be important to us being competitive, globally. But I think humanoids will play a big role in that overall. There's an interesting story of robotics where, the U.S. invented the very first industrial robot. It went into a General Motors factory in 1961, so over 60 years ago. And the U.S. really sort of pulled away from robotics by the 80s. And you can see what happened to manufacturing. There's an interesting sort of lesson in that. A lot of people look at China's manufacturing dominance today, and many people think of China as the low-cost manufacturing destination in the world. But that actually is not true. That hasn't been true for about the last decade. They're the high-tech manufacturing destination in the world. And in part, that's been done by using robots. So China actually has more robots deployed than the rest of the world combined. And they're buying more robots today than really anyone else globally, by several factors. And so if we want to compete globally in the future, it will be important for us to really embrace technology. And I think that's going to be the key to unlocking a really exciting future for all of us.
I want to understand for future consumers at home, what is the pricing model? How will people be able to buy robots, have them in home? I think you've said before that you want an Apollo humanoid robot to cost less than a car eventually.
Yeah.
How far off are we from that?
There are robots today that are at those price points, but they're not necessarily, you're sort of thinking about this problem from two ways. There's very low cost robots that are trying to get better and better. And there's very high performance robots that you're trying to make cheaper. So different people are sort of approaching that problem in different ways. I do think this will be like cars. This is a complex machine that we'll have similar to the way we have cars, and there'll be different tiers. You can buy a moped for a couple $1,000s, or you can buy a Maserati for a couple $100,000. And so I think different people will have different tiers of these robots, but I think they'll be accessible to everyone. There's a variety of different ways that you can buy a robot today, similar to the ways you can buy a car today. So you can lease the robot, or you can just buy it outright and, add different sort of subscription services on top of it. So I think, 20 years from now is probably a good way to think about it. I think everyone will have a robot of some type. Many of those will be humanoids, but not all of them. And they'll be accessible to everybody.
Last question, since you mentioned 20 years from now, just set the scene for us. What do you think is going to be the norm, the default when it comes to our interactions with humanoid robots?
I think it will be very commonplace that we interact with these robots. I think this will be just like computers. There was all these fears about computers and even things like, Big Brother, right? These were big sort of ideas back in the 80s. And now I have 3 computers that I'm carrying with me at all times, right? I have a very powerful computer on my wrist. I have a phone that has 4 cameras on it. I have and I have another computer that I carry in my backpack. And so I think this will be very similar to sort of the trajectory for robotics overall. I think we'll have robots in most homes, if not every home. Those will be everything from the Roomba to the full humanoid. Those will be everything from simplified cooking robots to these more general purpose robots. But I think they'll be an everyday part of our lives. And I think it'll be very hard to envision our lives before we had robots as we sort of look ahead.
I could talk to you for much longer, Jeff. I have so many questions, but we'll save that for next time. Thank you again, Jeff, for joining us today.
Thanks for having me on.